let's give this problem a try. So we're going to simplify the cube root of 36a squared times b to the negative 3 times d to the 7th over 1/2 a to the negative 1b squared c to the 4th. Okay, so basically it's the cube root of this quotient right here. Okay, we want to simplify it. So what simplify it means is, can we pull anything outside of that radical? And then of course we want to make sure that our denominator is rationalized. So the first tip I have for you when simplifying radicals, and you've seen this if you've watched other videos, okay, is to write our numbers, okay, as a product of their prime factors, okay? So we are going to write it as 36 is going to be 2 times 2 times 3 times 3, okay, because 36 we know is 4 times 9, so 2 times 2 times 3 times 3, okay? And then in our denominator, again, we're just working with the numbers right now, 1/2, okay? So this is interesting, and the reason that we're doing this second is because if you notice, we've got a 2, a 2, a 3, and a 3, and we can write 1/2 as 2 to the something, okay? So think about it. We can write 1/2 as 2 to the negative 1. There's a reason I'm doing that, okay? Oh, and let's not forget that this is the cube root. Okay, good. Now, so we've handled our numbers right now. We're going to deal with this number in a second, okay? Now let's handle our variables. So the first thing is we don't want negative exponents. Remember, math is the best subject ever. It is so awesome. We don't want negativity. Check you later, negativity. So no negative exponents. All right. So we've got an a to the negative 1 down here. So I used to always tell my students, imagine you're in a house, you have a upper level and a bottom level, and if your exponent is negative, it's unhappy. And how can it get happy? It changes levels. So this a to the first is going to come up, so we're going to end up on the top with a to the third, because again, this a to the first takes the elevator up. Perfect. Next up, we've got a b to the negative 3 over here. So that's unhappy, so what do? It's going to switch levels. It's going to come down. And that's going to give us, since we already have a b squared down here, that's going to give us a b to the 5th. Okay? And then d to the 7th is happy as a clam up there, so it's just going to stay. And c to the 4th is happy as a clam down there, so it's just going to stay. Now, let's go back to 2 to the negative 1. What's going to happen there? It's actually going to take the elevator up. Because it's negative, it wants to be happy, so it's going to go upstairs. So what I'm going to do here is maybe I'll just kind of move that radical symbol slightly so I can add another 2 in here, and then this is going to go away. All right. Now, the next thing we're going to do is, instead of writing a to the 3rd, d to the 7th, I want to write it all the way out. So a times a times a, and then d times d until I have 7 of them, etc. And the same with the denominator, okay? If you watch other videos that I have, you can see why I do this, and maybe I'll even make a video where I explain in a little more depth why I do this. But basically, it's a great way to organize and to know how many to pull out and stuff like that from underneath the radical symbol, all right? So we're going to also apply the property that allows us to basically split this radical to cube root numerator, cube root denominator. And remember, that's one of your properties, okay? So we're going to do those two things I just mentioned at the same time. So we are going to distribute the cube root to the numerator and denominator. So in the numerator, we're going to have 2 times 2 times 2, because remember I had moved that 2 up, times 3 times 3. Then we have 3 A's and 7 D's. I know that's a lot, so you're going to see what's going to happen here in a second. Over, okay, and it's going to be cube root. Okay, and in the denominator, we've got 5 B's, and we've got 4 C's. Okay, so let's just double check. 1, 2, 3, 4, 5, 6, 7. Good. Okay, 3, 4, 5, 3, and 2. Okay, perfect. All right, so now, remember, because it's cube root, we need groups of 3, because if you think about it, let me just take an aside over here. If we all know that a to the 3rd is also written as a times a times a, Okay, and if we're taking the third root, we know the cube root of a to the third is just a. This is a great visual though. This is a cubed. So we can just say, oh, well, we have 3 because we need 3 of them. That's the number we need to get to basically get to a, regular old a, all right? So for every 3 we see, we cross it out and we bring 1 outside, okay? So we are going to apply that to here. So remember, because we're doing cube roots, we are looking for 3 of one thing, okay? So the first thing I'm going to notice here is, and you know what, maybe I'll switch colors so we can see a little better. Okay, so I have 3 2s, which means I can circle it, cross it out, and bring 1 out front, okay? I don't have 3 3s, so those are going to have to stay underneath. I do have 3 A's, so I can cross it out and bring 1 outside. And again, this is multiplication on the outside. I'm kind of running out of room, but I'll clean it up when I bring it over there. And then for D's, I've got these 3 D's, so 1 can come outside times D. And then look, I can get even 3 more D's, boom. So that'll be actually D squared. So D squared times A times 2 on the outside, okay? And then for our denominator, I've got 3 B's, so 1 can come out. I can't make another group of 3, so those 2 B's are going to have to hang out in there. And then I've got 3 C's, so 1 can come out, okay? Perfect. Now, I want you to note what's left. I've got 3 3's and a D left in my numerator and 2 B's and a C left in my denominator. So let's clean it up and write it over there. So I'm looking at, and I'm just going to reorder this slightly. So I'm looking at 2AD squared times the cube root of, we can just make it 9 because it's 3 times 3. D, because we're not going to be able to simplify that anymore, so we don't need to worry about writing it as a product of its prime factors. And then in my denominator, okay, I've got CB, or we'll do it as BC in alphabetical order there, and then times the third root of B squared C. Or, you know what, I'm going to do B times C, and you're going to see why in a second, okay? Now, you might be saying, I'm done, and I'm going to say, not yet, but that's really good. We're on the right track, but we're not quite done yet because we have a radical in the denominator, okay? And we don't want a radical in the denominator, so what we need to do is we need to rationalize that denominator. We need to remove the radical, okay? Now, I know when you've seen things in class like 1 over root 2, your teachers probably said, oh, just multiply by root 2 over root 2. Boom, you get root 2 over 2 because root 2 times root 2 is 2 and 1 times root 2 is root 2, and you are all set. Easy peasy, right? But it's a little bit more complex than that. What your teacher has done has created a perfect square in order to take the square root. So that can work when we're dealing with square roots. But what if we're dealing with cube roots? We need to make perfect cubes, not perfect squares. So you may be thinking to yourself, well, so I'm just going to erase this so I have room. You may be thinking to yourself, well, I can just multiply by, okay, I can just multiply by the cube root of what this is, b times c. And then, of course, whatever you do to the denominator, you have to do to the numerator. Otherwise, you change the value of the expression. But wait a second, you didn't create a perfect cube there. You created b to the 4th c squared, which isn't going to help because you can pull out a b, but then you're going to have a b squared c squared underneath. Okay, so I don't want you to think about it as, you know, kind of autopiloting where you just, I'm just going to multiply by the radical that's in the denominator to eliminate it. That doesn't work. So that's the one thing I worry about if you're coming from just doing square roots and just simply multiplying by whatever the radical is in the denominator, because it can't be applied to cube roots, 4th roots, 5th roots. You have to understand the concept of creating perfect cubes, okay? So let's think about this. I'm going to erase this, okay? I'm going to leave the cube root there because we're going to do something with it. All right, so if I want to create a perfect cube, I've got 2 B's, okay? And remember, perfect cubes are when we have 3 of them, right? Well, I just need 1 more B. So it's just going to be B times, and then I need to create a perfect cube with c, okay? Well, if I have one c already, I need 2 more to create a perfect cube, so it's going to be times c, okay? And then again, whatever you do to the denominator, you must do to the numerator, otherwise you change the value of the expression, okay? All right, so now we're going to multiply this through with the radicals, okay? And I am going to do a second step in here so that you can see. So AD squared times the cube root of 9D times B times C, okay? Over BC times the cube root of, okay, we've got B times B times B times C times C times C. Boom, okay? Now, look at this. Look at this. Oh my gosh, this is so exciting. I have got 3 B's, so I can cross it out and bring 1 outside. I've got 3 C's, so I can cross it out and bring 1 outside. And basically what's left here is 1. It doesn't go to 0 because some students think, oh, it's 0, but then they're like, oh, then the whole denominator is 0. No, that's not the case. It basically drops to 1 and this becomes times 1, okay? So you can either say it gets eliminated, but don't call it 0 because that's not really what happened. Okay, now I've rationalized my denominator. I don't have a radical in the denominator anymore, okay? So I'm going to rewrite that, and I'm going to multiply this through and alphabetize it, if you will. So I've got 2AD squared times the 3rd root of, and I'm going to go 9, and then I don't have any A's. I got a B. I got 2 C's, so we're going to write it as C squared, and I got a D. Okay? Over, and then in my denominator, I've got B times B times C times C, so that's just going to be B squared, C squared. Okay? So there you go.